Welcome to this Learning Set 3 unit review. It's for the third and final test for the book, PS2, and it's for lessons 8 through 11. We've already had two tests for the earlier lessons, and this is part one. I'm going to break the video into two smaller parts so they're not so long. So here are some possible questions that might appear on the test. And one of the first things I'll always advise you to do is make sure you read all the directions. So when I look through here, I'm going to pick up a highlighter quick. That's what you're seeing there. So when I start to read this, the drawing shows an apple tree or an apple falling to the ground. Position 3 is the instant before the apple hits. So one of the common things that happen is when people look at this, they'll ask, okay, this one right here, it looks like it's touching the ground. But if I read carefully, it says it's the instant before the apple hits the ground. So I'm going to use the drawing to answer the following questions. In which of the three positions does the apple have the most gravitational energy? So gravitational energy is something we've been talking about since day one in this unit. Remember, gravitational energy is dependent on height. So the one that has the most gravitational energy will be the one that has the most height. So this makes it position A, or position 1, which is letter A here. In which of the three positions does the apple have the most kinetic energy? So remember, kinetic energy is dependent on mass and speed. Now, they're all the same apple. So mass does not really impact it at all, but speed does. So which one of these three will have the greatest speed? Well, if you were to drop something off a high building or a cliff, when you first drop it, it's hardly going at all. But the farther it goes down, the faster it gets. So this would have to be position 3. So position 1, it's got a lot of height, but if it's being held, it's got no speed at all, so it can't be that one. And it can't be position 2 because it's in the middle. It's probably about 50-50. So the correct answer is position 3, which is letter D. In which position is the apple's total energy the greatest? So I underlined this word for a reason. Total energy. So as you are going down, as the apple is falling, the GE, here we go, the level of GE is decreasing. What's happening to KE? The kinetic energy. It's going up, isn't it? So it actually, when one's going down, the other one's going up. So it's not losing any energy, it's just being converted from one GE to KE. So it has the same total energy in all three positions. So let's move to the next slide. Now this is something we've been working on since the beginning of the year as well. And so when we look at this, first, again, I'm going to read the directions. What two factors determine how much of that type of energy an object has? Okay, so the first thing I'm going to read is the word two. And you can see that the word two is bolded. So that tells me I need to have 2 for each one of these. Now, if these look familiar, we've done these countless times. We reviewed right before the test. This was, I believe, lesson 8.1 you had to do these, or homework 8.1, and we reviewed them in class as well right then. So when we look at elastic energy, what 2 factors determine how much that type of energy an object has? So if I think about it, the first thing is how rigid it is. And think of it like this. If I had 2 rulers, and we used rulers in class, if one was one of those flexi rulers that just flops all over the place, is that going to have much elastic energy? No. But a wooden ruler that has that's more rigid would be able to produce more elastic energy. What's the other thing? The other thing is that big D word, deformation. And when I talk about deformation, keep in mind that things need to come back to their original shape in order to have elastic energy. So if I take a can and I bend it and I step on it, it's deformed, absolutely. But it can't come back to the original shape, so it's not going to have any elastic energy. Gravitational energy, we just talked about that. It's what 2 things? Height, right? What's the other one? You guys remember? Just mention them. It's mass. Now, kinetic energy we talked about as well in our last slide. So kinetic energy is dependent on, do you remember? We mentioned speed, and we also mentioned one other thing. We mentioned mass as well. Seems like mass gets used a lot. How about thermal energy? Do you remember thermal energy? We covered this not too long ago. So thermal energy is going to be dependent on, yep, mass again. And thermal energy is going to be dependent on the temperature, how hot or cold it is. Something that's warmer is going to have more thermal energy than something that's colder. And the one we covered the most recent is chemical energy. Chemical energy is dependent on two things. If you're thinking it's mass again, because almost everything else was, you're absolutely right. So it's mass, and then what? If you remember, it's the type of substance. And remember, we tested for this. We had the, let me finish writing this first. We had the steel wool, and we had the aluminum foil that we put into copper chloride. And the steel wool hardly reacted at all. The temperature went up a little bit, but with the aluminum, the temperature went up quite a bit. So we actually tested for this in class. We actually tested for this in class as well. So the last slide I want to talk about in part one. Okay, again, it looks like it's a longer set of information, so I'm going to read it carefully. Tanisha takes a Coleman cooler that is at room temperature and places a few room temperature Cokes in it. She takes a bag of ice out of the freezer and places it in the cooler. She then closes the cooler. After a while, she opens the cooler and finds that the Cokes and the air in the cooler are colder than when she originally closed the cooler. So I'm going to use this information to answer the question. Okay, so let's look through this. Which object or objects, so it could be more than one, it also says circle as many that are appropriate, in the cooler lost thermal energy? Okay, so if they lost thermal energy, that means they should be getting cooler. Okay, so let's look through here. Did the ice get cooler? Did the Cokes get cooler? Did the air in the cooler get cooler? Or did none of them? Well, after a while, she opens the cooler and finds that the Cokes and the air in the cooler are colder. So air in the cooler and Coke. So I should know this, but I also could just read and find the answer. So which objects gain thermal energy? And if they gain, keep in mind that means they got warmer. So did the Cokes get warmer? No. Did the air in the cooler get colder? No. How about the ice? Yeah, because the ice melts. So it must be that answer. And then finally, explain what happened to the molecules in a Coke after it was in the cooler for an hour. So we can look at the fact that the air, it's not going to freeze solid. And neither are the Cokes if you put ice in there. So we're not necessarily talking about the molecules getting really close together and they stop interchanging with each other. But when we talk about temperature, because we talked about thermal energy here, we talked about thermal energy here. So explain what happened to the molecules in a Coke after it was in the cooler for an hour. Well, what's going to happen to those molecules? So what's going to happen at the molecular level? Well, what they're going to happen is that those molecules are going to start to slow down, right? There's going to be less motion. And remember, that's what temperature is. It's the average kinetic energy. It's the average of those molecules moving around. So if the molecules move around faster, it's going to have higher temps. If it's going to move slower, it's going to have lower temps. So if you have any questions about this first review, make sure you guys ask in class. Okay, thanks.